Welcome, everyone. The event is now live. John, please take it away.
Hi, everyone. Welcome to the Choosing Your Cloud Summit. Today's event was organized by the hardworking folks at Virtualization and Cloud Review and Redmond Magazine, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsors, Citrix and Red Hat, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of 3 information-packed sessions. But before we get started, I need to go over a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsors, Citrix and Red Hat, have provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. And last but not least, at the end of the 3rd session, one lucky attendee will be receiving a Surface Pro 7, Microsoft's ultralight tablet, which you must be present to win, so stick with us. And now on to our first session, State of the Cloud, the what and why of public versus private versus hybrid versus multi-cloud. For this session, we've called on technologist, content creator, and senior resultant, Howard M. Cohen. In his 35-plus years in the IT industry, Howard has held senior executive positions in many of the top channel partner organizations, and he currently writes for and about the IT channel. Howard is a sought-after speaker, an insightful observer of the technology landscape, and he's one of our favorite presenters. You're in for a great session. Take it away, Howard.
Thank you very much for that introduction, John. John's introductions always make me feel great. Hello, everybody. I want to thank you personally for joining us today. I especially want to thank those of you who took the time this morning to send us good morning greetings on the Q&A panel. Obviously, you've been to our presentations before. You know the Q&A panel. We really appreciate the greetings. It's hard to get engagement in a medium like this, and every little bit counts. So thank you very much for that. As John said, we're here to talk about the what, when, why of public versus private versus hybrid versus multi-cloud. I love, as a writer, I love words. So frequently, if you've been to any of my presentations, you'll see me defining words first and talking about those words and the impact of those words. Well, the 3 words I want to first deal with today are what, when, and why. That's what we're here for, the what, when, and why of clouds. Okay. Somebody's playing with the slides. Okay, so the what, when, and why of clouds. I'd actually like to kind of turn that around a little bit and instead start off with the why, then do the when, then do the what. So bear with me. That's the sequence I'm going to move in. Other words that we need to kind of focus a little bit in on are public, private, hybrid, and multi-cloud. These words are used a lot in our language, in our discourse. We should really agree upon what they mean to us. So let's start with hybrid. No, I never like going in list order. So here's the thing about hybrid. You hear it all the time. You have to decide whether or not you're going to go to a hybrid cloud. And I don't get that. Personally, I'm confused by that. Because when you come down to it, everything is hybrid. Absolutely everything. How many of us have only public cloud? We don't use anything else. We have nothing on-prem. We have no private cloud servers out there. We just use public cloud. And I'm sure that there's somebody in the crowd who will say yes to that. And that's great. That's great. But overall, when you take it net across the world, everything is hybrid. The laptop that you're carrying with you is probably a hybrid laptop and tablet. It's one, not the other. It's both. So to me, everything is hybrid. So I kind of dispense with the word often. I don't see a whole lot of import to it. When you're dealing with hybrid, of course, now we want to also deal with the word multi-cloud. Hybrid and multi-cloud. And of course, people are asking all the time, what's the difference? Well, this may be a good way to think of it. Every hybrid is multi-cloud, just like every square is a rectangle, right? However, not every multi-cloud is hybrid. What do I mean? So hybrid, it really talks about having public and private cloud in the same environment, maybe on-prem too. Whereas multi-cloud really talks about using the same kind of cloud, but multiple clouds. So for example, if you were to be using AWS, Azure, and Google Cloud, or any combination thereof, that is multi-cloud. So it's really multi-public cloud, if you will. Multi-private cloud, everybody's on multi-private cloud. You have multiple servers, you're in multi-private cloud. But really what we're talking about when we talk about multi-cloud is combining multiple public cloud providers to get to where we want to go. So let's get down now to definitions of these words. And by the way, the definitions I'm going to give you here were provided by Red Hat, one of our sponsors today. I thought they were very good, so I thought these would be the best to share. Public is a cloud environment that you don't own. It's not your servers, it's not your data center, it's just that you use the resources that are on it. And so do other customers, other tenants. It's a pool of shared resources, as the cloud definition says. So that's public cloud. Private cloud is loosely defined. I don't know why it's loosely, but it's basically all for one user. It's not shared by any other company other than the one company that owns it or uses it. And note at the bottom it says sometimes on-premise. This has been a point of confusion for people for a lot of years. Everybody thought, well, it's cloud, it's got to be elsewhere. It's got to be in the cloud, not on your premises. But that's really not the case. Private cloud describes a set of characteristics set forth in NIST publication 800-175. Somebody correct me if I got the number wrong. The definition of cloud computing. 4 pages. If you have not read it, go find it on the NIST website. It's easy to get a hold of, worth the time to read. Tells you all the characteristics of cloud computing. It defines cloud computing for you. Things like self-service, pool of shared resources, the layer of abstraction between the users and the underlying technology, lots of stuff. And it's a really well-written, tight, quick document that's very, 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 very valuable. So it could be on your premises, it could be elsewhere, but it's private only to you. Hybrid says that you've got a combination. And hopefully your workloads can move between them, so you can orchestrate them to do that. You can manage them together, but not necessarily. Hybrid just means you have more than one kind in your environment. And then multi-cloud. Basically, it's more than one cloud of the same kind. In private, I don't think it has any meaning whatsoever. In public, most people think of the hyperscalers. The fact is, there are a lot of great smaller cloud providers who give more of a boutique service than the 3 hyperscalers. And they're worth exploring because some of them do things that the hyperscalers don't. So just a tip on that. Okay, so what are the advantages of each? Well, let's deal with public first. Okay, public is really the lowest cost. You're not going to purchase any hardware. You're not going to purchase any software. And you're only going to pay for the service when you're using it. It's almost all based on consumption-based pricing. No maintenance. Not only no maintenance, but also no electricity. You don't have to power anything other than your endpoints. No cooling. Usually when you have a data center or a network room, it has to be cooled to a certain temperature to keep the equipment operating. You don't do any of that. That's all gone. You don't have people running your data center because you don't have a data center, and you're not renting space for it. You don't need to maintain space for it. You just need an endpoint, and you can access public cloud. It should be unlimited scalability. If you're hitting the top limits of a public cloud's scalability, that's a heck of a lot of storage you're using there. But seriously, they have plenty of storage ready and available, and you can instantly spin it up. If you need a couple more terabytes, just click on the self-service console, you've got them. No ordering hard drives, no installing or formatting or any of the other stuff that we've been doing for decades. Just request it. They're obviously highly reliable. They got multiple redundant servers, multiple redundant data centers in most cases. They're not going to go down. This is the business they're in. Whenever they go down, boy, everybody hears about it. And it is inherently multi-tenant. It is meant to be shared by more than one company or organization, if you will. Private ostensibly gives you more flexibility in that you're configuring everything that happens on it. No application goes on without you deciding to put that application on. And you can put whatever combination of applications you want, whatever combination of workloads you want, as long as you can configure your hardware appropriately. This, of course, means you have more control over it. You're making all the decisions. You're running the thing. It's your server or servers. In more scalability, I'll take a little bit of issue with that in that, in public, more often than not, you're not really even thinking about how much storage. That just kind of works. In private, you've got to think about it. You've got to plan for it. You don't want to be paying for storage that you're not using. In public cloud, you just don't. Here, you make decisions about buying more equipment. And of course, private is inherently single tenant. It's meant all for one company. It's private. Advantages of hybrid, it's the best of both, right? You have public for what you need public for, private for what you need private for, then you have total control over the environment. If you want to have a new application, you can put it in your private server. If the application is out there and available, you can get it on your public server. Just subscribe to it. Fantastic. Very flexible. Cost effectiveness in that you're shopping. You can pick and choose the application you want from the source you want and the way you want. So the hybrid is giving you more choice, a broader spectrum, if you will. Nobody really thinks about this. They just do it. And that's why I say everything is hybrid. It's just kind of inherently where we end up going when we configure a cloud environment. I should also talk about ease. Ease of transition is a very important topic that we don't talk about enough. Some people's initial cloud excursions failed because they tried to do everything at once. They tried to move all their workloads over at one time, and that is an invitation to disaster. You want to move gradually, one workload at a time. You may choose to move the less expensive, less important workloads first to learn your lessons on that, or you may be driven by the urgency of needing to move to the cloud with bigger, more expensive, more valuable data assets. And in multi-cloud, this is really the best of all worlds, right? You get to exploit best-in-class features from whoever has them. The best of AWS, the best of Google, the best of Microsoft Azure. It's kind of like going to a mall where there are 3 anchors and they're all big department stores, right? They've got everything. And you want to pick up a pair of shoes. So you go to the first one and you don't really find the shoes that you like, but there's some you'd settle for. So you go to the second one, you fall in love with a pair of shoes. That's fabulous. That's the right price for me. They look great. They fit great. Yeah, but you know what? Let me check that third one to see if they have anything. You go, you don't really find anything that beats what you found, so you go back to that second department store and you take it there. You buy your shoes there. Same thing here. You can pick and choose the services you need from the provider who you feel provides them best, in best alignment with your applications, and at the best possible cost. There are certain applications and certain government agencies that require that you use a specific cloud provider to run their software. They're very few and far between, but they're out there. And so if you're required to use a cloud, you'll use that cloud. That doesn't mean you want to do everything else on that cloud. So that's when you'd go multi-cloud in that environment. You use one for whatever it's required for, and you use others for the other things you're doing. One way in which you go multi-cloud, and you can't help it, is when your company merges with or acquires another company or is acquired by another company. And they don't have the same cloud provider you do. Instantly, you have multi-cloud, and you need to manage it. You may manage your way out of one of them. You may not. You may find that there's real facility in having both and doing the things that you can do when you have more than one. That's important because there will be times when you can fail over from one to the other, and that's handy. It's very useful. Also, by having more than one, you avoid vendor lock-in. If all your workloads are on one cloud, you're kind of stuck with that cloud. Yes, you can transition. You definitely can move off of one cloud to another if you decide you need to. That is not a quick process. It is not without pain. It is not without cost. So you're going to hesitate to move unless you really, really have to. So you avoid that by already being signed up with multiple clouds. Then you can easily and gradually move over at your leisure, or just move the workloads you want. It's also a great way to keep costs down. Again, we went to those 3 big department stores. We chose the one that had the shoes we wanted at the best price. So in essence, we kept our cost on those shoes down. Same here. You're going to be consuming services from these providers. They each charge differently. So you will find that one has a better price. Not necessarily for long. They do compete with each other. They are very aware of each other's pricing, but you can be the beneficiary. Okay, so we said we would deal with the why, the when, and the what. Now that we know all of the advantages of each kind of cloud, now that we understand the definition of each kind of cloud, let's talk about why one versus the other. Now, of course, if you've attended any of my presentations, you've seen this. This is my Simon Sinek commercial. Read this book. The concept is a brilliant concept. Start with why. And if you think about it, everything we do should start with why. We should understand what's the driving force behind why we're doing what we're doing. And what I'm going to talk about is establish your decision criteria. More often than not, they'll be based on your desired business outcomes. It's not so much what you do it with as it is what you do. Focus on what it is you want to do. Focus on the outcomes you want to create and the impact you want to have on your business, which is usually increasing profit. Start with that. Get it really well defined. Be very specific and very clear about what you're setting out to accomplish with this new cloud environment you're building. From that, you can identify which workloads and applications you're going to be using to achieve those goals. So you can justify and validate each decision for a given application and for the construction of a given workload. And then once you've decided that, you're going to decide why you should choose one cloud over another cloud. It's kind of a simple sequence of events. As I alluded to earlier, there is a tendency to want to really go at it. And my advice is do not boil the ocean, or do not try to boil the ocean. And for those of you who are ecologically conscious, This is not an ocean boiling. This is a school of fish causing it to look like the ocean is boiling. So it's all okay. This is the point at which you need to decide when. What do I mean by decide when? You're going to have some short-term objectives that you want to achieve first. Okay, there are some things that this is why you're going to the cloud. These things must happen first. And that's great. That's great. If you can identify those and they're the kind of projects that get you some early wins. Early wins drive user adoption, and nothing will stop a project in its tracks faster than poor user adoption. The users have to adopt it or it's useless. So short-term planning, get the applications people really need where there's a big payoff for them and for your organization, and that's great. However, keep in mind and have in your near-term view what your next group of applications are going to be. Why? Because as you start to build your clouds, you do want to build it to be something that you can keep using on into the future. You don't want to have to be throwing away your investments and replacing them with new. That was much more important when everything was on-prem, sure, because you'd actually be throwing out hardware. You'd be forklifting stuff out of your data center, forklifting new stuff in. That's painful. Here, it's choosing one service over another, but again, it's still somewhat painful. You're still moving from one place to another, and eventually that will feel just as bad as the on-prem thing used to feel, because that's human nature. And then, of course, what are your long-term plans? You know, what are you going to accomplish ultimately? When you take the three together, you should have a very good picture of what you're going to accomplish and when you're going to accomplish it. And that helps tremendously when you're building your business case. It helps tremendously when you're trying to get executive buy-in. And it helps when you're trying to get user buy-in as well. So understanding your when is critical. It's very straightforward, but it's by no means easy. Which brings us to what? What are you going to do? Okay. Fortunately, I have prepared a checklist for you. Let's go through the checklist. This is a planning checklist. So you're going to determine your what. First, we're going to check off that we understand what we want to accomplish. Okay, we just did that in the why. That was great. And we know what applications will accomplish it. We decided that pretty much in the why and when. We know what capacities each workload will require. That's kind of new stuff. We have to start to really think about that. And you should be considering what capacities you're going to need. How much memory, how much storage, and how much compute power. You want to know these things in advance because you want to budget. You know, in a consumption-based billing world, you pay for everything you use, only when you use it. But the point is that you do pay for everything you use. And so you want to know how much you're going to be paying this year in storage. How much do you think you're going to be paying in the coming year for memory and compute and everything else you need from your cloud provider? You want to know who's going to be using the applications, what are the user communities we're going to serve, and what are their particular requirements. As you develop the applications, you're going to learn what you need in terms of special services. There are hundreds, maybe thousands of special services each cloud provider makes available. You're going to want to familiarize yourself with them because there'll be some applications that run infinitely better when you use those services. Ultimately, we need to know which cloud will serve each application best, and that's the place that we're at. We need to determine that. And so this is our planning checklist. Let's talk now about our planning process. How do we plan for these things? And what are the considerations we have to observe? Okay, so the first one up is cost, always. The difference between a great company and a poor company is that the great company knows its costs. Just that simple. If you don't know your costs, you're not going to stay in business long. So here we have to develop a mixed cost control and reduction strategy. We always want to control costs, but we also want to reduce them whenever and wherever we can. And in multi-cloud especially, tons of opportunities rise all the time. So we're going to want to stay aware of those. You have choices. You can choose a per seat service where you're paying X dollars per seat per month, per quarter, whatever, per period. And that's it. You have users who use each of those licenses. Of course, some of those users may leave. They may be terminated. They may decide to leave your company. And when they do, their license can't be given back. So it's ostensibly put into storage. It's idle. Then somebody else gets hired. And you onboard them, and somebody buys them their new license, and oops, why'd they buy them a new license? We have one in storage that's not being used. Let's use that first. You can't imagine how often that is not the case. How many people just simply ignore those stored up licenses, and they just sit there idle while more and more are purchased. Obviously, we're passing up a great opportunity to reduce cost. Great opportunity. So you need to have processes in place. When somebody new gets onboarded, do we have any existing licenses available to give them? And that little check alone in certain environments can save tens to hundreds of thousands of dollars a year. It's worth doing. You also need to be very, very careful that you have the right number of licenses for the number of users you have. If you don't, if people are somehow sharing licenses or pirating licenses, the software companies will find it out. They will detect it. And in many cases, they will come after you and they will sue you. And those suits have been decided in favor of the software publisher frequently. And the publisher gets a very, very, very big settlement in those cases. So you don't want to be the one paying that. Make sure that you're governing your licensing carefully and you have the right number of seats for the number of butts you're going to put in them. Okay. The other choice is consumption-based pricing. Sounds great. You only pay for what you use. Fantastic. As long as you keep track of what you use. You know, there's this funny thing. One of the characteristics of cloud is that you have this pool of shared resources. You can request a resource, and then when you're done with it, you release that resource. Fantastic. Unless you forget to release it. And then it just sits there idle. And while it sits there idle, you're officially using it. You've requested it. It's yours. And you are paying for it. In the earliest days of Azure, there was a moment at which the growth suddenly stopped. Sales growth just stalled. And the reason was that a lot of major companies had just received bills, invoices, some of them totaling hundreds of thousands of dollars in usage overages, consumption overages. Nobody was keeping an eye on consumption. Nobody was watching it. And people were forgetting to release their resources when they were finished using them. And so they were paying for nothing. They were being billed for nothing. And it got resolved in various and different ways. But the point is you don't want to be the next one to receive that career-altering bill, if you will. You'll also find in terms of saving costs that all the cloud providers offer something called a reserve, that resembles at least a reserved instance. That is to say, I'm going to be using this service at some point in the future. I want to reserve it now. I get a better price for that, especially if I'm reserving a lot of instances. If I'm doing a volume. There are specialty instance reservations. If you're willing to say, well, no matter what happens to the cost, I can't change what I've bought. So if the cost drops, you don't get that cost drop. But you get to pay less than you ordinarily would. It's a kind of, you're making a bet. You've got to really be careful. You've really got to look at the program, understand what the rules and regs are before you start taking advantage of any of them. Appreciate the value of automation. The more you can automate, the faster you can get things done, the more that you can keep your consumption down, which keeps your costs down. You're going to want to figure out how to charge departments back and how you track that. So you need the right tools for that. And you need visibility of everything. If you're going to control cost, you have to be able to see everything that you're paying for. So you're going to want an ad hoc, at the moment look at anything you need to look at. You're going to want monthly, quarterly, and yearly reports so you can figure out what your trends are. But be very demanding about visibility. Every application in use, every workload in use, every user who's on the system, virtual machines that get left hanging out there that aren't used. There's all kinds of things to watch for. You need to be able to see what's going on around you. And this way you can avoid overage charges. Next up is service level agreements. And really in our context, it's service level objectives. What are we going to provide to our user community? It's a contract between us, the cloud service provider, and our users. Now, notice that hybrid manager of cloud spells HMC. I like that a lot. But seriously, what's defined in your service level objectives has to have a strategy built for it that exists in your management too. How are we going to achieve those objectives? What are we going to do to make sure we do? Basically, all of this is built around managing your users' expectations. You don't want to disappoint your users. You don't want to let them down. So let them know what they can expect and then deliver what you say you're going to deliver. This is your best way of preserving that layer of abstraction I mentioned before, where the users are on one side of the layer, the underlying technology is on the other side, and they never connect. The users just use. They just worry about the work they're there to do. They don't have to worry about where the storage is or what the memory is, or they don't have to worry about anything. They just put their hands on the keyboard and get to work. You're going to be worried about availability. Service level agreements usually describe a quality of service, quality defined in terms of availability. This is the famous 5 nines. When you've heard 5 nines, that means that we're committing that the system will be available 99.999% of the time. It will only be down 0.0001%, which is still a couple of days, maybe a week. So that's still downtime. But that's the expectation that we're setting, that basically almost always available. There are many cloud services that offer 3 nines. Some that are even honest enough to offer a 99.5%. And I suspect we'll see that tail downward a little bit. And also specific performance. When you say you're going to be able to make available a certain amount of memory and a certain amount of processing power, it's got to be there. And finally, the last quality that you want to commit to is resilience. And that's really a part of availability. That all kinds of things can happen, mistakes, errors, attacks, acts of God, what have you. But the system can continue to be available by building in more and more system resilience. Okay, the first thing that's on everybody's mind lately is, of course, security. We're all worried about security. It's getting compromised so much all around us. Security begins with the user. So you're going to need cross-cloud credentials, the ability to log into all the clouds. You may use a single sign-on solution for that. But the user has got to be authenticated to each of the systems they use. They have to receive authorization to use the specific resources from each of those clouds. And you have to also provide access control. Basically, that says that not only the user needs to be authenticated, but the device too. We want to look at the device, interrogate the device, make sure that it's configured properly, make sure that it is what it says it is, and that it's properly protected and has enough security built into it that we can allow it onto the network. You want to basically validate the user and their device. That's the first step. The second step, and this may actually just be all the time, is that you want to be constantly on the hunt. You want to be looking for trouble. You want to be out there hunting for cyber threats on the network. And there's various platforms and tools Some of the platforms do it for you over the cloud. Some of them, you have your own staff do it with the tools provided. But it's crucial to be looking for the trouble before the trouble gets to you. This is what kind of led to the progress from intrusion detection to protection to prevention. It was great to detect an intrusion, but by then they were already in. So we wanted to protect against that, not let them in. We know they're there, but we're not letting them in. Then we said that's not even enough. We want to prevent them from even getting to the door. We want to stop them in their tracks long before they get to us. Next step is probably prediction, where we're able to predict where threats are going to come from and just close the doors well in advance. This will continue to get better and better and better. The bottom line is you want to catch threats before they become dangerous. Of course, you have to have anti-malware. There is a new malware threat introduced into the internet every 39 seconds, according to a recent survey. 39 seconds. That's about 2,500 a day. That's a lot. And you have to be ready for all of them. And that's why you're constantly downloading more and more signatures. You've got to have a good strategy for protecting yourself against all the nasties that are being put out there to attack you. And then, of course, there's everybody's favorite compromise, phishing, which, of course, leads to ransomware. A phishing email is just that. It looks fishy. Okay, or maybe it doesn't look so fishy. Maybe it looks real. It's from your bank, or it's from one of your partners, it's your lawyer, or what have you. Somebody you know. And it looks like it's coming from them. It's their colors, it's their logo, their typography. It looks like it's from them. If you're being careful, and if you're interrogating each email thoroughly, you'll notice that the O in their name is actually a 0 in the URL. Well, that's not right. And you can't basically tell if an L has been exchanged with a 1. So you may think you're looking at the word you're thinking of, but it's not. A reformed URL is probably the easiest way that you can spot a phishing email. There are much more sophisticated ways. And once you click on the link they ask you to click on, or you open the attachment they ask you to open, that's all she wrote. All hell breaks loose. And then the ransom note comes, if you want your data back, you got to pay this ransom. Not fun. The best way to protect yourself, there's actually two, but one of them is encryption. It doesn't help you if you lost your data, if they've stolen it or corrupted it, but it does help you if they're trying to steal your data, because then they'll end up with gibberish. And you just don't have to worry about them using your data, because it's not understandable. As long as they can't get their hands on the key. You don't need to share the key with anybody. Not with the cloud provider, nobody. And when the cloud provider doesn't have the key, here's another level of protection. Protection against the government. If you interrogate all of your cloud contracts, you will find that they all say that they will give up your data if they receive a subpoena. They'll give it up. Well, they don't tell you. Nobody notifies you. If they don't have the key, the government then has to come and get it from you. Now, yes, you have to obey that subpoena and give them the key, but now at least you know. Now you know the government is looking at your data, and you can start whatever legal protection you need to do to protect yourself. So keep everything encrypted. And make sure that however you're actioning your alerts, that it's policy-based and automated. Use automation as much as possible. If you're depending upon a person to see a red light go on a screen and then pick up a phone, you've introduced a really powerful point of failure. Automate your alerts as much as you possibly can. I wanted to touch briefly on compliance. Compliance is not security. They're not the same thing. You can be fully compliant with the regulations that affect you, but not be anywhere near secure. You can accomplish that. You can also be very secure. You can have incredible security and still not be compliant with the regulations. They're two different things. You need two different people or two different teams addressing them. And compliance is not just about technology, not just your technology that has to be compliant. People have to comply too. People have to do what is specified in the act. They have to fill out certain forms. They have to file certain filings. That's part of being compliant, and you have to check for that as well. Be aware that no products will say that they are HIPAA compliant or PCI compliant or what have you. They're not. There's no such thing. Products cannot be compliant. Only you are compliant. Now, products can be certified to contribute to your compliance, but unto themselves, they are not. I also want to mention that in most regulations, you not only have to be compliant, you have to document your compliance and prove that the things you've done and documented have been effective. When you get ready for an audit, that's just reality. You're usually going to encounter three levels of what could be considered regulations. The first one we're all familiar with, government regulatory acts. The second one is any technical policies from your providers. Your public cloud providers may have specific rules of things you cannot do with their software. And then the last is company policies. If you're doing it right, you have established a policy for your users. You expect them to abide by that policy. So that's a level of regulation that they need to be concerned with sticking with. So your strategies to achieve and to maintain compliance include the establishment of a policy up front, workflow automation to track the completion of all the things that must be done to be compliant, internal automated compliance surveys like we discussed, and you need to always be in the mode of preparing for audits. Crucial. Other planning for governance. Gartner defines information governance as the specification of this, who's going to make the decisions, who's going to decide what to use, who's going to decide who gets access to what, who's going to decide where things are stored. You have to identify who is, because if you don't, people may start obeying the instructions of somebody who's not authorized to give those instructions. You need an accountability framework that people understand this is the value of the data asset that I am liable for if I'm the one using it. When is it going to be archived? When are records going to be deleted? There are certain records that have to be deleted after a certain period of time. Often you set that in your own policy. You have to make sure you have governance checking to make sure that that is adhered to. In a lot of regulations, the regulation stipulates that you have to adhere to your own requirements. You set the requirement, you fulfill the requirement. And if you don't fulfill your own requirement, you're fined. So, and governance is responsible for enforcing the processes, the roles, the policies, everything that ensure effective and efficient use of your network and the information that rides on it. There are more and more products being introduced all the time now that will automate the governance process, that will check for you to make sure that people are doing what they're supposed to be doing, to make sure the documents are filled out properly. They use artificial intelligence and machine learning. Some of it's really exciting stuff. Start looking out for that. We're getting down to the data. By the way, I'm really glad that Scott Becker is not with us today. I did not include the bacon slide. So if anybody sees Scott, tell him he didn't miss it. Every data entity must be evaluated. You must know the value of every data asset. These are probably, and it says right here in The Economist, your most valuable resource, your most valuable asset are your data assets. And so you've got to be extremely, extremely careful to know the value. Why? You don't want to spend more on protecting it than it's worth. That's one thing. And two, I mean, this is a balance sheet reality. the value that you establish for your data goes on your balance sheet. So be very stringent about data valuation. You have to establish strict backup procedures. Not for nothing, but backup is your second best defense against ransomware. If you've got a backup of the data they stole, you just restore the backup and off you go. Which means you've got to be careful to be checking and constantly reassuring the integrity of the data. Is the database fully intact and uncorrupted? Sovereignty is an issue. Where's your server? If you're using the cloud, where is the cloud server? Clouds are data centers. Are you using a data center that's located in a company that allows your data in it? Or are you using a server that's in a country outside your country, and that's forbidden? Depending on which country you're involved with, data sovereignty can become a big issue. And of course, you need to have an acceptable use policy so that everybody knows what they can and cannot do with the data. And one more time, I'll keep on hammering it home, always encrypt your data. Whether it's at rest in storage or in flight across the network, it's always encrypted. So now we're down to choosing our applications and planning which ones we're going to use. Which apps are best served from where? Which apps are best served from AWS versus Azure versus Google? Which apps are best served from public cloud versus private cloud? Many of your own apps that will probably be on private cloud are currently monolithic apps, the way they used to be developed. Basically, monolithic apps are all one big block of text, one big block of code, rather. And if anything goes wrong, that whole big block of code comes crashing down. Any error can force the entire system to stop, and then everybody sits idle. Today, we've developed cloud-native applications, cloud-native development languages, and a cloud-native technology that creates microservices, where each microservice is a piece of what used to be in the monolith, and each microservice is put into a container with all the resources it needs to run. These containers are very portable. They can move all over the cloud to wherever they're needed. And if one of them fails, if there is an error, it gets destroyed instantly and reinstantiated. A new copy is popped right out. You don't even know that there was an error. So in terms of resilience, a whole new dimension of resilience. You're going to want to perform container optimization to make sure that your containers travel as quickly and as effortlessly as possible on the different network environments you're using. Scheduling them to move where they go is a process called orchestration. You want to make sure that you have systems in place to perform that. You definitely want to consider DevOps. DevOps accelerates the deployment of applications by bringing back feedback very quickly. The operators deploy it, get feedback quickly, bring it back to the developers. The developers create another version, and then the cycle goes around and around and around. It's an iterative process meant to achieve continuous improvement through continuous deployment. And in a microservices environment, it's almost mandatory. But it is a cultural change. It's a big change, so be prepared for that. And yes, you want to make sure that you consider your artificial intelligence and machine learning issues. If you are indeed choosing application or developing applications, you want to know that you're working on the platform that serves them best. Big data issues are also a concern. Can your cloud handle the level of data, the quantity of data, the velocity of data, and the variety of data that you're looking at? And then there will always be migration issues. What kind of tools are available to help you move from wherever you were to the clouds of your choice? Now, we talked about hybrid infrastructure. I'm going to run through this very quickly because we're kind of getting out of time. Your goal is to have one console. Why? One console is for your network infrastructure, your on-prem infrastructure, your cloud services. It'd be preferable if all of that was in one console so that you could see everything in context. You can compare and contrast. You can say, is this one working better than that one? And you can make decisions that maybe I want to move to a different service on a different cloud because this isn't operating adequately. You can only do that if you can see it all in context. And the only way to do that is to bring it together. You're going to be managing management complexity, and you're going to be managing scalability. And so each of those is an issue that you're going to have to contend with. Your goal, ultimately, is seamless management of everything. Now, it's not easy today. It's getting easier. It's easier than it was yesterday. It'll be easier tomorrow. Hang in with it, and you'll see that the tools are coming every day. You want to reduce tool sprawl. You want to get down to one tool. And if they change something in the front end, you can bet they're changing something in the back end, so you need to be aware of that. I'm just going to race through these slides because they just provide more detail to the four things we've just talked about. Serverless, on-prem infrastructure that is serverless, no such thing. The definition of serverless are servers that you don't maintain. That's what serverless really means. So you can't have a serverless on-prem. You've all seen all of these. The bottom line on cloud services is that someday everything will be available as a service. And so that's kind of where we're moving. I particularly put up UC because I think unified communications is one of the most important applications you can bring to the cloud, and then decide which cloud you're using to do that. Okay. The panacea ultimately is one ring to rule them all, one platform to manage them all. So here's what you need to know, and I'll be really quick about this because I can see we're right up at the end of time. When we're talking about the hyperscalers, they each offer hundreds of services. Some have the same name but do different things. Some do the same thing, but they do that thing differently. Some do that thing better than others do that thing. Each is priced differently, and those prices are always changing. They offer different virtual machine configurations to support different kinds of workloads. Become familiar with that and figure out who's going to offer you the best combination. You can have just about any operating system, any database, any utilities you like to use on just about any cloud. They're all very similar, but they're not the same. And so you've got to be studying the difference at all times. Remember that each has its own pricing specials, and the price is always changing, actually trending downward, which is great. Their programs, the pricing programs are changing. The whole overall architecture can change from time to time. You need a financial manager on your team who will keep track of all of that at all times. And that's your method for keeping your costs down. You also need a technology specialist who's going to stay on top of all the different services and how they're different. Okay. If you know all that and you've just made all those decisions and understand all those requirements, good news, you are now finally ready to start selecting clouds. And you're very satisfied with that, right? With that, I apologize for leaving so little time, John, but do we have any questions?
No, there are just a couple of questions. That was awesome, Howard, as usual. The attendees definitely got their money's worth this time. Let's see here. So we'll start with this one. How has multi-factor authentication been affected between the different environments?
How has it been affected between the different environments? Well, the one big difference is each of them deploy it differently, although they're getting to be very, very consistent. I mean, there was a time when you got the cool factor, right? The old days of the cool factor. The cool factor was that you were given a secure ID key fob, right? And it had a key ring on it, and you could put your keys on it. And when you were at lunch and you took your keys out and people saw your secure ID fob, they said, "Ooh, you're cool." It was a device that received a it was always 6 digits, 6-digit number from a server, an authentication server. And you entered that after your password, and then it let you in. It was two-factor authentication. And by the way, all two-factor is multi-factor, but not all multi-factor is two-factor. You may have more factors. But the good thing about the fob was that it combined something you have, that fob, with something that you know, your password. And so there was a two-step that combined. There are many other biometric ways to do it. There are retina scan devices. There is software that can read the way you type, and from your typing cadence determine that you're you. It's kind of amazing when you see it in action. There's all kinds of ways to do it. Today, most everybody is using your mobile device to send you your release code. Some platforms, like Microsoft, especially the Authenticator, are releasing authentication software. But I'm watching the way this is rolling out, and I suspect that Authenticator will go, and they'll just decide that, sending out a code or calling in for a code, that's just fine. That just works.
Mm-hmm. Here's another one. Have you seen a lot of companies moving away from a purely cloud-based solution to a hybrid solution?
All right, say it again. From purely cloud solutions to
a hybrid solution. Yeah, I see what the confusion is.
A hybrid solution is a cloud solution. So yes, I
what's the trend you're seeing here?
You will see companies move to from a single cloud to hybrid. First of all, because that's the nature of the cloud. It's not the cloud. It's the clouds. It's always been the cloud. Mm-hmm. It's all about mixing and matching the cloud services you want to use so that they all work well together. And your management challenge is making them all play nicely in the sandbox together. But when you've got a private cloud server and you're running your core business applications on it, and then suddenly you see Office 365, you say, ooh, or Google Workplace. Say, ooh, that's better than buying software every year. You've suddenly gone hybrid. You've added a public cloud to your private cloud. So, yeah, that's the trend.
Okay. What is a rule of thumb on how incremental work/cost is needed to run a private cloud versus public or hybrid cloud? Is there
the rule of thumb? If I were to come up with
go ahead.
If I were to come up with a rule of thumb, the ratio you have to establish is between, first of all, does the private cloud solution and the public cloud solution solve your problem equally? Do they fulfill your objectives equally? If they are fulfilled equally, then the least expensive one is the one you're going to choose, presuming that they're both from reliable cloud providers. That's another thing. You make sure you're working only with reliable cloud providers. They're handling your data. Don't go wading in that pond there. Yeah. So that would be my
that seems like a good. Okay. That seems like a good segue to this question. How has the increase in ransomware attacks affected the migration to the cloud? Has it slowed things down? Are people a little more timid, or is there what's been the impact?
In 2012, Microsoft engaged a survey company to run a survey that basically asked executives which allows you to sleep better at night, knowing that everything is on your premises or knowing that everything is in the cloud. It's 2012. And the overwhelming majority of executives said cloud, that they feel much safer in the cloud. And asked to justify it, they all talked about how cloud providers are able to spend a whole lot more than any given company on securing their cloud, securing their servers, securing their network. And so ransomware, if it's me, I would rather have my data in storage in a cloud service than have it here in my office, because my office is going to be a whole lot easier to penetrate. Also, the key to success in terms of storage is to constantly back up your data incrementally so that you always have a complete backup as often as possible, and that you observe the 3-2-1 rule. 3 copies of the data on 2 different kinds of media, and one of them unreachable. Now today, because these cyber criminals are now going past your live data and they're attacking your backup data too, then, well, you need to have a copy that's air-gapped, that's on a server, that's on a server that's not connected to the network. It's crazy, but that's really where we're at, and there are services that can do that. You need to be very, very protective. To me, they can be more protective than I can. I've got a great firewall, love my firewall, but I know theirs is better.
Eek. That was a great session, Howard, but we've run out of time for questions. Thank you, my friend. That was awesome.
Thank you. And thank you all.
Okay, okay, everybody, we're going to take a short break, but we'll be back at the time in a few minutes. We'll put it that way for our second session. Pain points, when to consider switching or evolving your cloud architecture, led by the awesome Carlos Rivas, Senior Solutions Architect at Intervision Systems, and moderated by my esteemed colleague, David Remmel, Editor-in-Chief of Virtualization and Cloud Review. Many thanks to Howard M. Cohen for a great session, and to our sponsors, Citrix and Red Hat, for making it possible. Now would be a great time to check those extra resources on your console provided by our sponsors. And remember, during today's third session, we'll be giving away a Microsoft Surface Pro 7. But you must be present to win, so stay tuned. Back in a few.
Welcome, everyone. The event is now live. David, please take it away.
Okay, welcome back, everyone. Thank you for being here. Thank you to our speakers, my fellow moderators, and of course our sponsors, Citrix and Red Hat, for underwriting this summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, and I'm here to moderate the second session of our summit. This session is called Pain Points, When to Consider Switching or Evolving Your Cloud Architecture. Our speaker for this session is Carlos Rivas, Senior Solutions Architect at Intervision Systems. He helps California community colleges move their traditional data centers to the cloud, and he has worked for several large telecommunication providers, managing and configuring network devices using numerous tools and languages, including Java, Groovy, Python, Perl, and PHP. He's also a cloud computing instructor for LinkedIn Learning and Udacity. Carlos, it's great to have you here. Please take it away.
Thank you, and good morning, good afternoon, or good evening to everybody, depending on where you are in the world. Really excited to share this session with you guys. This is going to be a little different today because we're going to attack the problem from the source and then go back to a solution, as opposed to my traditional presentation where I just give you an active solution and tell you to go ahead and do it. So we're going to go a little in reverse here. Little housekeeping before we get into that. Here's my information on my LinkedIn, and feel free to reach out if you have questions about cloud or anything technology related, such as DevOps, for example. I'd be more than happy to connect with you and help you find the answers you're looking for. So as I mentioned, today we're going to be talking about pain points regarding your cloud, and we're going to do it a little bit backwards. So we're going to first mention a specific pain point that I've been able to identify while working with various customers in the cloud space. And then I'm going to discuss what could you do to get out of that particular pain point, and then perhaps provide you with specific solutions and diagrams that you can use to be able to proceed with that specific solution. So with that, let's just get into it right away. Let's see here. Okay, the first one is going to be the account access. And by account, I mean if you have, let's say, a cloud account that you use for development, perhaps a different one, isolated one for production and test, each one of those accounts is going to require some sort of login credential so that people can get in there and do their job. The problem with this is that you're going to start creating all these user credentials all over the place, and that creates a potential weakness there when you have people that could be potentially repeating passwords all over the place because they don't want to have to remember an additional one, and perhaps some of these people have passwords that are really old or not using multi-factor and that kind of thing. So it can become problematic. So the solution to this, to a pain point like this, would be something like, consolidating. For example, getting back into the problem. So you have all these users' accounts, as I just mentioned, and even some of those accounts could have like root credentials, like access to billing, access to taking over the account. Also the two-factor issue, like if you couldn't, let's say that you have a production account and you enforce the two-factor in there, that's great. But then you may have a development account that has the two-factor disabled, and it can get problematic. The same thing goes for password policies. Or you have to have all these policies in place to say, okay, I need people to change their password every 90 days, for example, and enforce that. And again, if this isn't centralized, it can really become a significant problem. So first thing first, there's not much you can do regarding root credentials. So what I recommend in that case is once you have an account that requires root credentials, you go ahead and establish that and set a very complex password, whatever you need to do, enable two-factor authentication, of course, and then just lock it away. You don't need the account. That's why most cloud providers will have what is known as a root credential that you can use for admin task, but they will also have an administrator type of level where you can do everything within that account without the potential of, taking over the account or something like that. So you don't really need the root credentials except for very, exceptional tasks, such as changing billing information or account ownership or something like that. Something very critical. So just lock those things away, right? Now, regarding all those users that I just mentioned accessing your various cloud environments, I highly recommend having some sort of centralized identity management. The most popular in the commercial sector is always going to be Active Directory, Microsoft Active Directory, and it plays well with any and all cloud providers. From what I've seen, it's very easy to integrate Active Directory to AWS, for example, or obviously Microsoft Azure. You can do those integrations very, very simple. And the same goes for password policies. You can enforce two-factor authentications and and manage all those policies from a centralized location. It's very, very simple to do in my experience. So what tools do I recommend to make this a reality? As I mentioned, probably you're going to find Google Suite in the educational sector, schools, school districts, and Active Directory in the commercial sector. And you can use those centralized repositories of credentials that are already secure to manage, to use those as login for your cloud environment. If you need something specific, like let's say you don't have these tools, you can go to a third-party solution. There's Ping Identity, there's OAuth, there's Okta. You can, and these provide all kinds of security, not only in the sense of, password policies, but also they can serve as your two-factor authentication providers as well, and also as your centralized login for various web applications that you provide to your users. So you should consider third-party login providers if you don't want to mess with Active Directory or Google Suite for whatever reason. These are really, really good. I've used pretty much all of these. My favorite, I would say, is Okta of this third-party list. And the cool thing about single sign-on is that they're mostly SAML compatible, which is a standard of exchanging credentials. So you can use this, like I said, you can use it in Azure, you can use it in AWS, you can use it in Google Cloud, and it will be more or less the exact same setup. So once you learn how to do one, you will be more than okay moving forward, even if you change cloud providers as you go along. This is an example of what it would look like, doing a single sign-on, for example, where you would have AWS SSO in a master account, and then that information can trickle down in the form of access roles, or as is shown in this diagram as permission sets. And you can just trickle that down to your entire environment. For example, here we have a development account and production accounts. And you can pass this information down, in the form of permissions. And it's really great because, like I said, you only have that one location where you have to manage credentials, reset password, or an employee joining the company or employee leaving the company. And you just go to this one place and just make that little change. And then you know that your environment is always going to be in sync in that sense. You don't have to worry about, I have to go to all these accounts to make sure that nobody, can access because they have 3 passwords. It's just a mess, and it can lead to security breaches. And, that's a significant pain point for sure. So you want to avoid those situations by centralizing, using a tool. In this example, I'm showing AWS SSO, for example. Using that very same tool, I wanted to show this additional slide because not only does it help with your own particular tools in your own environment, but you can also use external third-party tools. For example, you can connect SSO and use that login information to, if you want to connect Dropbox, if you want to connect Slack or Office 365. It's really amazing that because of what I mentioned about SAML assertions, you can connect pretty much anything to the single centralized location. And then, like I said, it saves you a ton of time. Imagine being able to have all these additional apps that you keep adding to your environment, and every time you add a new app, nobody needs to remember a new password or register or create credentials or anything like that. You just make the app available, and it will take the necessary credentials off of your SSO solution. It's a really great way to manage permission in a safe way where you don't have to worry about forgetting to reset somebody's password or something like that in case they're moving into the company or leaving the company. So moving away from that, let's talk about infrastructure changes. What I mean by this is when you have a scenario where you have a network and you have an on-prem network and you want this cloud provider to talk to your on-prem network, and you start growing a little bit, and things can get pretty dicey quickly if you don't know how to expand. For example, you have a manually provisioned infrastructure. What that means is you created a certain subnet, or you deployed a server or something like that, and those things that you did is not documented anywhere because you did it manually using the console provided by your cloud provider in this case. And that leads to hard-coded values. For example, you have a server that has 80 gigabytes, for example. Like, nobody knows this machine has 80 gigabytes if it's not documented somewhere in some configuration file, or if it's like if you just went ahead and did it, that's not a great situation to have. The same goes for change history. Like, let's say this same server that has 80 gigabytes is now almost full, and you go ahead and you go to the console, and now the server is 120 gigabytes because you needed the additional space. But again, if this isn't documented, like, there's no way to move forward here. If something happens, so let's say that you have to refresh the environment or create another copy for development purposes, you're not going to know, hey, is this server still supposed to have 80 gigabytes of space, or is it 120? Like, what's going on here, right? So that happens when you work manually. So if you can avoid that, please do, because otherwise it creates a mess as the technical debt keeps mounting, right? And the same, before moving away from the slides, I'd like to mention the situation about rollbacks. What I mean by this is if you make a change in a production environment and something breaks, how easy is it for you to say, I want to go back. I want to go back to the previous configuration. If you did the change manually, you're done pretty much, because unless you have a checklist of exactly everything you did and you're able and comfortable to undo it, you have a problem there. So this is another advantage of keeping track of infrastructure changes if you're using some kind of tool. And this is what we're going to discuss now for the solution. What I recommend is an infrastructure management tool that is paired with version control. So what that's going to give you is the ability to make changes, keep track of changes, and also be able to keep a history of every change that you've made. And when you combine this with some kind of automation, that's what we know as DevOps today, or infrastructure as code, or configuration management, all those things where you hear something like Terraform or Ansible or Chef. All those tools are designed for this type of task. For my solution here, I recommend something like Terraform, and that's what I'm using right now, mainly because it's very kind of cloud neutral, if you will. So if you learn to use this tool, it can help you with any of your cloud providers. You don't have to be tied to any one of them. And the goal here is to, write a little script in Terraform, and that's the only downside, of course, because it's a tool and it has a script in behind it that you will have to learn how to use this tool, obviously. And what this tool is going to do for you is, resource management, or everything I just mentioned earlier in the pain point on solutions. Let's say I want to create a server, keep going to that server example, and you create it with 80 gigabytes, but everybody can see that because now you have a code file that shows exactly what you did to create the server. And once you run this Terraform script, it will connect to your cloud provider with credentials, of course, and create this infrastructure for you, whether it's a subnet, a server, a routing rule, whatever you need. And it's always going to be, the script itself is self-documented because you're basically writing everything that you want to see happen. And let's see here. We have also CloudFormation, and of course this one is AWS specific, not us, Terraform, which is kind of independent there. And CloudFormation, what it does is it's kind of the same, but I wanted to highlight this one because it's a lot simpler than Terraform. This doesn't have kind of logic in there. It's just really a template that can be either JSON format or YAML format, and it's going to be just a listing of resources. It doesn't have much logic to it, but still it's a really good tool that you can use to be able to declare your resources and run it through CloudFormation, and it will deploy everything to your environment. Moving on here, and this is where I mentioned the automation part or the DevOps part of the deal, which is you have a repository, some Git-compatible repository. In this case, I'm showing GitHub, where you would have your little scripts or your CloudFormation templates or something that will have that particular resource declaration, your server declaration, whether it's networking or servers or anything like that. And then you can run this through an automation. In this case, I'm showing AWS Code Pipeline, but it could be something like Jenkins or Circle CI or any sort of automation tool like that. And once you have this thing, you can run it through there. It will run CloudFormation. It will deploy your resources, and then that's it. If something happens along the way, you can always say, hey, I don't like this change. It's actually breaking stuff. You can always just go back to the repository and say, I want to roll back to the previous version so I can remove the change that I did. And you don't have to know which change you did because that's what the version control software is for. And once that happens, you just redeploy once you roll back, and everything goes away. Everything goes back exactly to where it was. So you have this ability to roll back very, very quickly in the event of a crash or an undesirable result. Moving on to our next pain point, and this is very much related to what I would just mention, but this one can really creep up on you if you let it, which is the network topology pain point. Let me explain. So usually you move to the cloud and you have this little network. You declare a network, usually is 10.00/16, and say, hey, I have this VPC with this particular network mask, and that's all I need. I'm going to declare maybe a couple of subnets in there, and that's it. The problem with this design is that if you don't consider expansion, that's when it becomes a problem. Because 6 months from now, somebody might say, well, we have this VPC, but we want to separate, for the reasons of security, we want to separate development workloads from production workloads. Well, you could say, well, I'm just going to create a different VPC, perhaps in a different account. And what that's going to be is, okay, now we're going to call this one production. Well, if you keep doing that now, let's say for another test environment or something like that, now you are in a situation where you have all these separate networks that at some point may need to talk to one another, and now you have a routing mess in your hands. So that's a little bit of a problem there, especially if you combine all these networks that I just mentioned with the ability to talk to your on-prem network. Again, this is when things can get very dicey very quickly, and it can creep up on you if you let it. So something to keep in mind is that whenever you create a networking space in the cloud, whatever your cloud vendor may be, keep in mind and consider that it may need to talk to your other environments as well as your on-prem environment. So what do I recommend to solve this problem? Well, you have something like a transit gateway, which is, like I said, it's available in all various cloud providers. What this does is it allows connectivity back and forth across networks. Simpler solutions are something like a VPN. A VPN is usually where you're just going to connect your on-prem network to a specific one of your networks in the cloud. Or something like VPC peering, which is the simplest solution. Actually, you can do this in a couple clicks in pretty much any of the cloud providers. And this is just to provide back and forth connectivity across two networks. The only requirement for VPC peering is that they must be non-conflicting networks. So if you have a 10.0.0.0 network, your other peer needs to be different addressing. It cannot be 10.0.0 again because you're going to have potential IP collisions there. So that's the only downside there, but that's probably the cheapest and simplest solution is you just need to connect two cloud networks to one another. This is what it looks like, that VPC peering I just mentioned. You would have, in this example, VPC-A is a 10.0.0 network, and you connect that to a 172.31 network, and it's very, very simple. You just establish that peering connection, and then, the machines can talk to one another. It can get really tricky if you say, well, I want to connect the VPC-A to my on-prem network, through a VPN, so I can talk to the machines from my internal network to the cloud. No problem there. But the problem comes when you have this connectivity and you want to reach a machine on VPC-V, and you only have a VPN on VPC-A. So it can get tricky very, very quickly. So that's why this is the simplest solution and may not be the best case for everyone out there. Now, of course, if you have something, like I mentioned, this is a VPN, but in this case, it's just a single VPC, not multiple. And this is great if you're starting out. If you just have like a production VPC or a development VPC and you wanted to connect it to your on-prem network, well, that's perfect. But, again, consider the expansion. So if we go to the next slide here, this is what the transit gateway looks like. The transit gateway is a centralized location that you can use to VPN to the transit gateway, and then from there you can add routing rules that are specific to transit. In this case, I want to be able to talk to development. I want to be able to talk to production and testing. You can do all of this with a single VPN connection to the transit gateway, because that is the purpose of this tool, is just to provide transitive networking across, back and forth from all your various networks. Again, of course, consider the network addressing for every one of these components, because you don't want the same IP address. It would be a disaster if you have the same IP space in several of these, right? You want to make sure that you're allocating specific IP addresses for the various networks that you have here. So moving on to a slightly different one, which is monolithic software. This pain point refers to not having the ability to break up your application into components that allow you to provide higher availability, because everything is contained in a single point. So this single piece of software is going to allow you to serve your application, and that's great. There's nothing wrong with that. This type of architecture works just fine for a lot of people. But the problem is you want to provide, if you're moving this to the cloud, you want to provide high availability, and you also want to provide some sort of scalability, right? So this is not something that you want to just have it sit there like, okay, what happens if you get 10 times the normal number of users at the same time hitting this application? You may be in a situation when this application, is really hard to scale, is really hard to make available to others, because you can't really break it up into components. So the obvious solution in this case is to, of course, if you have access to the source code of this thing, is to break it up into smaller components known as microservices. And then you can take these smaller components and say, I want to run this component inside a Docker container, for example. Or I want to be able to have these two components just talk to each other using messaging which makes them loosely coupled, meaning that one of them can fail and not really affect the other. And by the way, that's the biggest pain point about a monolithic architecture, is that when one component fails, because it's part of the entire application, everything comes crashing down. But if you have like a microservices or something that is loosely coupled, you can have components fail and then just take your sweet time to bring it back online and available to others, and not have to worry about, let's say I'm not able to receive orders in my e-commerce store because the shipping functionality is down. That doesn't really make sense. You should be able to have an application that is able to receive orders, even if, let's say, the accounting is down or the shipping department is down. Those components should not affect overall functionalities, and that's one of the main advantages of using containers and a microservice architecture. Now, this is what it looks like graphically speaking. Everything I just said. It's just once you have all the components separated, as you can see on the left, I have the monolithic architecture where everything is in a single one, and if one of them crashes, the whole application comes crashing down. But once you break it up into smaller components, it's a lot easier for you to say, give me an additional 10 of these components because now we have all this traffic, and it's great to have that ability to break up your application. Again, I understand that it may not be the case for everybody. This huge spaghetti mess of a diagram that you're looking at is an implementation of a WordPress in Amazon Web Services. What they're doing here is saying, and by the way, before I continue, WordPress is very, very monolithic, which is not great, but using something like AWS, you can sort of break it up into things that are usable in this case. But just keep in mind that WordPress is very, very monolithic. It's one application that you install in one place, it connects to a database, and that's it. But in this case, what they're doing is they recommend put a load balancer in front of the application, and then you can deploy the same application in various servers that are your backend environment, and then you can connect that to a highly available database shown here in blue that you can split the database into a primary and a secondary. So you get this illusion of microservices, if you will, where you have the application broken down into highly available components. But again, WordPress is very monolithic in this sense. In fact, the only way that this works is because the red component, the one that says Amazon EFS, that component is shared across all the various copies of WordPress that are running here to give you the illusion that you're running multiple copies of WordPress to be able to handle whatever number of traffic you're expecting in this particular and this fictional website. So it's something to keep in mind that there are situations where you can, even though you cannot break up the application into microservices, you can still get away with certain things. And this is one of those cases when you can make the application highly available, even though it's not suitable for breaking up into microservices. And moving along with the same train of thought, we're talking about high availability now. Before I go to the next slide, let me define what I mean by highly available. In this case, what I mean is having an application that is always there. Even if the server crashes, it would have its own logic to restart and continue providing services. And also if you get a surge of users hitting your application so that it can scale and keep up with demand. That's my definition of highly available. For example, what would be the problem? Not having enough servers to meet demand, and that usually happens to e-commerce websites. When you have a certain holiday and you have a product that everybody wants, you may have more traffic in your hands that your application can handle based on the number of CPU and servers that you have running to back it up, right? The other side of the coin is having way too many servers where you're just paying, hey, all this traffic is going to come in, and it never actually happens. So you're paying for all these servers for no reason, right? Or you can go a different direction, and this is what I call the single server running on stable software, where you have a single machine that is more than enough for your needs, and you don't need more than one machine. But this machine, for some reason, sometimes it will go offline. So what you can do is you can set up a health check for this machine to make it available to others. And once you have this health check in there, if it ever fails, it will trigger the highly available scenario in this case, and it will shut down the machine and restart it. So this is one of those scenarios where you're not thinking about too little servers or too many servers. You just have one, and you just want to keep that one running. But high availability can still help you to keep that one running at all times by, establishing a health check that can help you trigger some logic when the health check fails. So what do I recommend for a solution? Autoscaling. And again, autoscaling is a solution that is available in Google Cloud. It's also available in Azure. It's available in all your various providers. And it's basically setting up some logic or some criteria that is going to say add more servers or remove servers based on this or that criteria. And of course, once you have all these servers providing your application to your users, you're going to need a load balancer. And the purpose of the load balancer is very, very simple. What it's going to do is just going to take all these traffic and it's going to spread the load across the many servers that you have available to provide it. And of course, another way to put this is to have a loosely coupled architecture that involves messaging. So in this case, you would have something monitoring the messaging queue. Let's say it's a message queue with a bunch of orders coming in. So if you say, well, if you get more than 1,000 orders at one time, it's time to start the auto-scaling process to add more servers to keep up, for example. That's something that is very, very popular and people do all the time. Here's an architecture with the load balancer, for example. The entry point for your user is going to be the DNS name of that load balancer, so they're going to connect to it. And you're going to have some kind of alarm to this load balancer, and the alarm is going to keep track of that traffic. Like when you get an excessive amount of traffic, what you're going to do is you're going to trigger a scaling event to add more servers. The opposite is also true. Once you get a normal or low amount of traffic, you can trigger a scaled down event, and that's going to keep the amount of servers that you have available more or less matching the amount of traffic that's coming in. And this is my favorite because I'm usually specialized in back-end applications. It's using messaging queues. You will have like a front end that is capturing orders or capturing messages from other applications, and those messages will go into some sort of queue. In this case, we have a priority queue and we have a secondary queue. And based on the number of messages coming into these queues, you can make a decision and say, hey, we need more servers or we need less servers. And the advantage of having more than one queue is that you can have higher performance servers, more expensive on the priority queue to keep those moving along. And you can, have a secondary queue that you can process at a slower pace, at less cost to use. There are many examples where I've seen this. If you go to a certain website or whatever, especially e-commerce, they will have, hey, would you like, rush processing? This is what they mean. They'll send it to a dedicated a server or a dedicated team that is going to process your order a lot faster than the normal one. So this is kind of like what it would look like to implement such an architecture. Now, here's another pain point, and I see this all the time because, I'm usually migrating customers to the cloud, and that's the pain point of traditional server migration. There's a certain value of moving to the cloud, but if you just move your servers exactly as they are on-prem and you move them to the cloud, after sometimes you're not really taking advantage. You're not really taking any of the benefits of the cloud. So it's one of those things that you have to keep in mind. For example, you move them as is to the cloud. Like, I just mentioned auto-scaling and the high availability and all that. If you just move your server to the cloud, you're not taking advantage of those things. You really have to make some refactoring and some changes to, take advantage of that. Another thing is, and this is a misconception that happens all the time, is that if you move a server as is to the cloud, it's going to have the exact same level of upkeep, meaning that if this server requires a database administrator and also a system administrator for the server to work, it's going to need the same human resources to keep operating. So just keep that in mind. And this one is very popular, and it's the one about wasting resources. So let's say you have a server, and the server has 16 gigabytes of RAM and 100 terabytes of disk space, but you're using, I don't know, you're using 10 or 20% of those machine resources. Well, guess what? If you move it to the cloud, you're going to be paying for these resources, even though you're not really using them. So it's also something to keep in mind. In the cloud, you can set up monitoring to say, hey, I'm never using more than, 20% of the CPU power of this machine. Why not downgrade the machine and save some money? So that's something that you can certainly do, but you have to be proactive and take advantage of that when you move to the cloud. So what do I propose for a solution for that? Is, as I just mentioned, just monitor the resource usage. So if you're wasting a bunch of disk space that you're not using at all, well, you can go ahead and reduce it and then expand it later as needed. And then, of course, you should consider a slow transition to cloud native. So take that server and say, I want to move this to the cloud, but I also want to say, I want this application to be turned into microservices over time. It doesn't have to be right away, right? It just slowly you want to get there and say, hey, I just want to change this component now. Maybe in 2 months I want to change that other component, and slowly evolve your application to cloud native. The same goes for the monolithic versus microservices, is that if it's possible and if you have access to the source code of the application, you can say, I don't need to change the source code, but I want to pull out this component and put it in a Docker container or something like that and just move it out of there. Because as soon as you start breaking things up, now you can start taking advantage of the cloud in a more efficient way. Usually the transition goes something like this. When you have, okay, I'm cloud ready, and, my application is actually easy to move to the cloud. It's not like super dependent on this operating system or that, and then I'm ready to move it. So once I move it to the cloud, is my application cloud friendly, for example? What does this mean? It means that can I tweak my application? Can I change configuration settings in my application without having to go in there? Just change a little configuration file and things like that, and just make it available to others. Is it a resilient type of application? For example, I just mentioned health check. Does this application provide me a health check that tells me whether the application is running properly or not? So those are little things that, again, it's kind of easy if you control the source code of the application. If you have access to the original developer, you can make changes and adjust as you go. Not so much if you're dealing with a legacy application that's been running for 20 or 30 years and you don't want to touch it. I understand. In those cases, there's very little that you can do. But in this particular slide, the goal is to get to the top, which is cloud native, where you're using a ton of services provided by the cloud, and then you don't really need to do any management because you kind of depend on your cloud provider in this case, and let them do what they're good at, which is providing highly available, secure applications, and then you just worry about your specific custom business functionality. So a few key points to take away from today is to, number one, follow domain best practices. So depending on exactly on what you're trying to do, I'm sure somebody else has done it before, and you can follow those very same patterns. And that goes to the microservice architecture. Everybody's using it these days. I'm sure there's an example that can fit your particular use case if you look hard enough. And if you can find something where you have something like the well-architected framework, you can sometimes call landing zone or something like that. And you can access those whether you're using AWS or Microsoft Azure. It doesn't matter. They all have what they call a reference architecture website where you can read white papers and how others are implementing similar solutions to what you're looking for. From the beginning part of my presentation, I want to highlight the use of automation and version control. I understand that if you come from an operational background and not a programming background, this can be a little bit of a pain point, something that you may not want to do, because I know that you might want to be, like those guys that go into the server, fix the problem, and move on with their lives. But version control, and it's a kind of self-documented process that can really help you as your cloud presence grows. It's really great, especially if you pair it up with automation, which we know as DevOps, because now you're just clicking a single button and it deploys your entire server, your entire configuration, your entire application. It's a good thing to have. And also remember, it is the cloud, it is dynamic, so don't be afraid to practice. Don't be afraid to ask questions. You can create networks, you can create servers, you can create those things, destroy them, rebuild them again, and keep practicing, and you'll get better at it for sure, and avoid those pain points going forward. And with that, I'll be more than happy to take your questions. David?
Okay, great. Great job, Carlos. We do have a lot of questions. And I'd like to remind the audience that we can answer questions until about 5 minutes to the top of the hour in order to give you a short break before the next presentation. So send them on in. So let's get right to it. So Carlos, you were earlier talking about breaking up monolithic applications, and you said you can do that if you have the source code. This question pertains to that. Can I break up an application into smaller microservices if I don't have the source code?
That is a great question, and that goes back to the part about having an application that is cloud-friendly, meaning that is this application, are you able to configure it using a configuration file without having to mess with hard-coded value? Another thing is, can I go into this application and disable certain components? It reminds me of the WordPress example that I just presented, where you can say, okay, I want this plugin, I don't want this other plugin, and those little things that you can enable or disable gives you the ability to make changes and make this application highly available without having to depend on, okay, now I need to find a programmer that can understand this source code so that we can make changes. For example, usually WordPress used to be, in the past, it used to run with the database in the same machine. But now, you can just take a configuration file and say, I want to point this implementation of WordPress to the database that is in the backend, and the backend happens to be a relational database service provided by a cloud provider. So those are little tricks that you can do to break up an application and turn it into sort of microservices, if you will, without actually having the need to access any sort of source code or modify the application in any way.
Okay, great. Next question. Can I use single sign-on for my own custom software?
Let's see. The quick answer is yes. When it comes to single sign-on, because there's a standard for it, the SAML assertion standard, you can certainly implement that. It's really just an XML file that is exchanged along with the security certificate. And yes, you can certainly find a library for this, for PHP, for Java, those languages. And once you implement this, yes, you can absolutely, once you do it for one, you can do it for all the others, because it's a standard, so it doesn't really change depending on cloud vendors or anything like that. So once you implement that change into your application, it kind of becomes open to receive any single sign-on that as long as they're using the same standard, and you can just make it available to any cloud provider without just that one change.
Okay, next question. Why not use multiple VPC peering connections instead of a transit gateway?
I actually like this question because, as I mentioned, VPC peering or VPC connectivity is kind of like it's very, very simple. It's very nice to implement. It's something that you can do essentially in a minute in pretty much any of the cloud providers, as long as the IPs don't collide with one another. Except the problem is that because there's no specific routing table associated with this peering, you cannot manage transitive routing, and that's the key distinction. And that's actually an exam question. You cannot do transitive routing, so you cannot just go through a VPC and pass traffic because, again, VPC peering is just provides connectivity, not routing. So you would not be able to connect. If you wanted to do that, you have to do a ton of back and forth VPC peering connection. It can get really, really bad really quickly. So that's why I recommend something like a centralized routing solution, like a Cisco or a Palo Alto, or a transit gateway, for example.
Okay, great. I'd like to remind the audience we have a few more minutes for questions, so feel free to send them on in. The next one reads, can I use a cloud-independent VPN and networking solution?
Cloud-independent. I actually done this once. And yes, there is a free solution. I believe it's called OpenVPN or something like that. You can actually set it up, set up your own server, and then use this server as some type of connection in the middle. So yes, it's certainly possible. And a commercial option would be, I've seen a virtual implementation of a Palo Alto firewall, and you can put those out there in your environment and use that as your transit gateway, if you will. So yeah, it is certainly possible to route traffic back and forth through a third-party solutions. Yes, it's something that I've seen. It's pretty interesting. It kind of puts the workload on you, so you're not really taking advantage of the cloud provider in this case to do the work for you. It would be your own responsibility, but it is certainly possible, and it's a very viable solution for sure.
Okay. Next question reads, what choices do I have to provide single sign-on to my users while also enforcing two-factor authentication?
Let's see. In this case, I would recommend, as I mentioned, some kind of third-party solution. Those are usually the best in this case, especially if you have users that are mostly remote all the time. I would highly recommend a third-party solution that you can enforce password policies. You can enforce perhaps use social logins and two-factor authentication using, it could be an app on their phone, or it could be an SMS message. And you don't need to implement all of those yourself. It's just a matter of getting a third-party solution and something like Okta or Ping or something like that. Those solutions are really, really great for this particular task because, like I said, it's just a quick integration into your environment, and that's it. You don't need to become an expert at any of these tools. You just go in there and say, hey, I want to enable this, 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 and that, and then do the integration once, and then you're done. And then, they'll provide you with an app that people can download and use that as their two-factor on their phone. Or if they don't have it, you can still enforce two-factor and saying, hey, even though you don't have the app for authentication, you can still receive perhaps an SMS text message and use that as your two-factor, for example. So those are my recommendations, to use a third-party a login vendor in this case.
Okay. Looks like we have time for one more question. And it reads, can I use GitHub as my repository for my cloud-based CI/CD pipelines?
In this case, I think I understand where the question is aiming, is that because GitHub is a kind of a community public type of repository, so it's not necessarily integrated with cloud vendors, but I would say, first of all, you can create private repositories that are secure in GitHub, and then I believe that's free right now. It used to be paid, but now after Microsoft acquired GitHub, now you can get those free private repos absolutely free, which is great. And then once you set it up like that, the answer is yes. I know, for example, AWS Code Pipeline, which is a CI/CD tool, it's integrated. It provides that functionality that you can use GitHub as your repository to be able to host your infrastructure as code, whether it's actual code or CloudFormation or Terraform or something like that. You can certainly use that tool for that purpose. The same goes for Microsoft Azure. You can certainly use this external repository, pull it in there using tools like Azure DevOps, for example. You can pull that data in and trigger your CI/CD process there for your particular builds. So yes, the answer is yes. You can certainly use GitHub for this.
Okay. Well, that's all the questions we have time for. So thanks again, Carlos, for your excellent presentation and answering those questions.
You're welcome. It was a pleasure.
Okay, everyone else, stay tuned. We're going to take a short break and be back at the top of the hour for our third session, Hottest Third-Party Products, and the giveaway of our Surface Pro 7. We'll be right back.
Welcome, everyone. The event is now live. Raquel, please take it away.
Hi, everyone, and welcome back to our third and final session of the day, Hottest Third-Party Products. Some quick notes before we start. We wanted to thank you all for attending, and please be sure to stick around to the end, not only because you'll be eligible to win that Surface Pro 7 in our random drawing, but also because when you leave, you'll be asked to take a short survey on your opinions of today's event. So please share those honest opinions with us, as our editors read every comment and they truly shape our future events. And speaking of future events, we really want to thank our sponsors, Citrix and Red Hat. Not only are we thrilled to be associated with companies like Citrix and Red Hat, but we know that they're sponsoring this event because they believe in this community and they want to support events like these. So if you could also show your support and appreciation by downloading their resources, visiting their sites, and contacting them for a demo, that would be wonderful. It's through their underwriting of these events that we can bring you more summits in the future. So with that, I am thrilled to announce our first sponsor of the third session, Citrix. We are so thankful to Citrix for sponsoring today's event, and please enjoy this short message from the Citrix team.
Your customers and employees expect a flawless application experience. But as you transition to hybrid multi-cloud and microservices-based applications, it's getting harder to meet those expectations. But it doesn't have to be. With Citrix Application Delivery Solutions, you can simplify operations as you choose the app infrastructure that's right for your business. Improve security and performance, and enable visibility for all kinds of apps, wherever they're running. Because Citrix Application Delivery Controllers are built on a single code base, you get operational consistency for any app, any environment, and any form factor. Citrix ADC makes it easy to secure all your apps and APIs with consistent security policies. Plus, you get the flexibility of pooled capacity licensing, so you can easily reallocate capacity across your ADC instances whenever and wherever you need it. Integration with all your preferred open source tools means you can get your microservices apps to production fast. And with holistic visibility through a single pane of glass, you gain actionable insights across your entire environment for faster troubleshooting. When your users expect an outstanding application experience, Citrix ADC delivers.
All right, and with that, I am thrilled to announce the second speaker for our third session today, Julia Villarreal Pellegrino, who is a distinguished architect of hybrid cloud at Red Hat. Julia, please take it away.
Hello everyone, my name is Julio Villarreal Pellegrino. I am a distinguished architect with Red Hat Services. Today I want to talk to you about how to open the cloud, or how to build an open hybrid cloud. When I talk to my customers, the main question that I ask them is, where are you running your applications and services today? That is the main topic of conversation usually. And I ask this question because I want to understand, where do you have the applications that run your business? Are they in the cloud? Are they on premises? Are they on bare metal servers? In virtual machines? Well, again, if you are like many of my customers, you are probably already using multiple clouds in addition to your private cloud or data center. And very likely, you are using bare metal systems and using systems, in some cases, at the edge. So if this is your case, your infrastructure platforms are already hybrid. The question is, do you have an architecture that is flexible enough to support this hybrid world? Can you scale your operation by leveraging an open hybrid cloud model? And part of that is what I want to talk more today. Now, you may be asking, what is this open hybrid cloud that you are talking about? So let me answer that to you. At Red Hat, we believe that open hybrid cloud can help you scale the way that your organization adopts cloud computing. And we have that vision for over 7 years right now. We believe that open hybrid cloud is the recommended strategy for architecting, developing, and operating a hybrid mix of applications, delivering a truly flexible cloud experience with the speed, stability, and scale required for digital business transformation. Now, in order to do so, we have specific products and consulting services in different models. And let me be clear that we also believe that one size does not fit all in this case. But what we share is a common technological foundation. And in this case, for us, our common technologies that enable our open hybrid cloud vision is Red Hat Enterprise Linux and our Kubernetes platform, Red Hat OpenShift. Now, in addition to this technological foundation, we believe that an open hybrid cloud involves using open platforms. When I talk about open platforms, I mean platforms that run both traditional and new cloud-native workloads anywhere, from the data center to the cloud computing, the public cloud providers, to the edge. Also, an open hybrid cloud adopts the idea of open development tools to build innovative applications faster that can be highly integrated and continuously deployed. Also incorporates open management technologies and systems to enable automation across application, systems, teams, and processes. In some cases, adopting open hybrid cloud could bring managed services to allow other companies to help you run your environments. It also brings training to bring that knowledge transfer that some things need in this new technology adoption process. And a partner ecosystem that could give our customers technologies that has been tested, supported, and certified to work with major cloud hardware and software providers. It is open in our view because it's based on enterprise open software for access to a stable community innovation. It is open because it uses open standards for broad compatibility and open APIs for flexible integrations. Now, an open hybrid cloud strategy will allow an IT organization to take the best of open source innovation and use it to deliver results for the business. And at Red Hat, we have a proven track record of delivering the enterprise open source innovation that is the foundation of open hybrid cloud. Now, having all that into consideration, I want to ask you one question today. What is happening in your world? What are the forcing functions that are driving your strategies and tactics right now in your digital transformation process, in your cloud journey? Think about, let's say, two of the things in top of your mind that are pushing you through this cloud adoption process. Now, organizations are changing, and innovation requires, in this case, speed, stability, and being able to scale. Years ago, like some vendors and some analysts used to tell people that you only need two of these. Like, hey, you're okay if you have a speed and a stability, or you could scale and have a speed. In reality, is that this new world, you will need the three of them. Let me put you one example in this COVID-19 world that we're living right now. There was a new survey from 2021 HBR Pulse survey, and 90% of the respondents said that COVID-19 has accelerated the timing of their organization transformation efforts. And that's maybe why you are here today. It's because you are in that situation, because you have to innovate just to keep up with the requirements that COVID brought to your organization and to your industry. So if you need to deliver solutions and business innovation faster, the question comes back to you. Are you on that situation that you need to bring new delivery models and revenue streams to your company? That you need to provide faster time to market? That you need to improve customer satisfaction in order to meet your organization goals? For us, in order to move faster with the stability and scale that you will need in this crazy hybrid mix of application, processes, people, and infrastructure, hybrid cloud is not enough. You will need an open hybrid cloud to help your development, architecture, and operation teams work together efficiently to deliver software with the speed, stability, and scale. And all of this with consistency across hybrid environments, from bare metal to public cloud to private clouds to edge sites if you need to. Now, this is, in our opinion, how an open hybrid cloud could allow you to run this new paradigm. And that's how can you provide flexibility and consistency to allow teams to build and run their software wherever they are best suited. Now, how do we see this array? The answer is a multi-cloud platform to support application modernization. That's our view. Is by having the Red Hat platform components, Red Hat Enterprise Linux, and Red Hat Enterprise Linux Core OS, and Red Hat OpenShift Data Foundation for the storage components, and Red Hat OpenShift himself, all these platform components that could run anywhere. And when I mean anywhere, that they could be run in bare metal, virtualization systems, private clouds, public clouds like AWS, Google Cloud, IBM Cloud, Microsoft Azure, or any other private cloud or public clouds, and at the edge. So having one platform that you could run anywhere to use with open standards, and that you could run your application layer on top of that platform, providing you that standardization that your business will need to drive consistency and to provide a bump to your innovation. The cloud for us is not a place where you go, but it's a way of doing computing. And in this case, all IT services, API-based, where you could get different services from different providers to build that foundation. And in the case of OpenShift, where you could have an application layer that is rich, in this case with Red Hat integration, Red Hat runtimes, process automation, data services, that could allow you to run your code, that could allow you to build your software faster. With at the same time providing your developers with a way to consume resources in our case with Red Hat Code-Ready workspaces. And adding to all this mix of platform, application, a management layer with Red Hat Advanced Cluster Management for Kubernetes that will allow you to provide discovery, policy, compliance, configuration, and deploy workloads in multiple clouds. And bringing automation and cloud tools like Red Hat Ansible, Red Hat Insights, Smart Management, Satellite. So a whole ecosystem to power your hybrid cloud journey. Everything based on open standards. That is our vision for an open hybrid cloud. It's bringing all that. It's bringing open platforms, development tools, open management technologies and systems, managed service, training, and a rich partner ecosystem, everything combined with the portfolio that could empower you to run applications and scale your business in these new paradigms. Now, how can we help you? So if you need more help, like this is a quick presentation, please feel free to let us know. You could engage with us at Red Hat Services. We're going to be more than happy to assist you with your hybrid cloud platform design, with migration from legacy infrastructure to cloud platforms, to help you manage your environments if you need, and to assist you with the process of security and compliance while adopting cloud platforms. Thank you very much, and have a nice conference.
All right, wonderful. Well, thank you so much, Julio, for being with us today. We're all out of time, but if you did have a question for Julio, please type your question in the Q&A box, and he will follow up with you shortly. And now it's time to announce the winner of our random drawing. Congratulations to Brian Smith from the Memorial Hospital of Gulfport. You have won the Surface Pro 7. Congratulations. Our team will be in touch with you on how you can claim your prize later this week. Well, everyone, thank you so much for joining. That is all for our summit today. You will receive a replay email in the next few days with a link to rewatch this summit and also with a link to the slides from today's presentation. We truly hope you enjoyed today's event, and please do take that survey that pops up when you exit. Thank you again to our sponsors, Citrix and Red Hat, and have a great rest of your day, everyone.